Hey everybody, welcome to our webinar today, Electrical Panels, How to Avoid Panel Upgrades. I'm Joe Warchunas with Electrify Now, here as always with my teammate Brian Stewart. We'll introduce our panelists in just a second. Great to have you with us. Today's webinar is brought to you by Electrify Now. Of course, we're an all-volunteer organization promoting electrification as the quickest path to decarbonization and something we can all take an active part in achieving. You can get more resources to help you on your electrification journey at electrifynow.net. And San Diego Learn, which is a workforce education and training program that's partnered with us at Electrify Now to offer these free energy efficiency and electrification webinars. Please visit the Learn website for more info. We'll put links in the chat. So today's webinar is part of our Go Electric series. All year we've been looking at the benefits of electrification for homeowners, which of course include lower energy bills in most areas, cleaner indoor air, less pollution outside, more comfort, and increased safety. And today we're talking about electrical panels. So we know that electrical panels are the power center of every home, where your power comes in and gets distributed to all the receptacles and appliances. But when you're converting your home from gas or other fossil fuels to an all-electric home, you may need more power. And you're likely to be told that by many electricians that you'll need a panel upgrade. But if your home has a small panel and you need to upgrade it to a larger panel, this can be a barrier because it can be expensive, and it also creates some other challenges for the upstream electrical infrastructure. You might have to upgrade the service, and this might we'll look into the whole host of challenges that might create. So avoiding a panel upgrade has a lot of additional benefits. It benefits for you and also the entire electrical system. So today we're looking at how to determine if your home needs a panel upgrade or not. What is power efficient design, or it's also known as the Watt diet, and how can that reduce costs? What about smart panels? Are they right for your home? And are there incentives to upgrade your electrical panel? This map shows a little cross-section of the United States that shows who's using what fuels to heat their homes. Now, space heating, of course, is the biggest energy user in the home. And about half of the country currently burns fossil fuels in their homes. And that is important because if you're going to switch that to electricity, you may have to look at your electrical panel and see if it's big enough. Now, this is, of course, true mostly in the north, where you have that heating loads. In the south, you already have usually the AC there, and so your electrical system might not need any sort of altering. So this graph shows the U.S. residential housing stock by the year the homes were built, and you can see that in the 1980s, around 200 amp panels became standard, and in the 1960s, 100 amp panels became standard. So about 50% of homes of the U.S. housing stock currently was built before the 200 amp and 100 amps panels became standard. Now, that doesn't mean those homes all have smaller than 100 amp panels. A lot of folks have upgraded their panels along the way. But if you live in a home that's built earlier than the 1980s, you probably want to look at your electrical panel. We'll talk about that today.
Great. Well, thanks, Joe. So let's talk about how you can even tell what size panel you have. So most people are going to see something like what's on the left, which is a modern electrical panel. So if you've had any kind of electrical work done in your home in the last 20 or 30 years, you're probably going to see a panel that looks something like this. And you can look at the main breaker, and usually it's printed right on the main breaker there what the panel size is, because this is how many amps are coming into the breaker. So this one, it's hard to see here, but it says 100 amps. But most panels are going to say it there. They may also have it printed on the label on the inside of the panel door. But sometimes you're going to have a panel that doesn't have those two things on it. Another place you can, and by the way, typically what you're going to see is 100, 150, or 200. Those are the most common panel sizes, but there are some other ones, but those are the most common ones. The other way you can see how big your service is to go to look at your meter, and you'll see that there's this little thing that says, it'll say CL, and then it'll have a number after it. In this case, it's saying CL 200. That means that there's 200 amps of service to this meter from the electric utility. So that's another way to get a sense of how much of a service you have to your home. There's some situations where those two numbers might not match. That's unusual, but that is possible. And both are going to be, we'll talk about how both come into play. Okay, if you have an older fuser panel, like if you go look at your panel and it looks like one of these, either a fuse box, the really old ones, or a split bus panel, which was not uncommon in the 70s for these to be put in. Neither of these really correspond to modern electrical code, so you're probably going to want to do some upgrading, regardless of the panel. It doesn't necessarily mean you need a service upgrade, and we'll talk about the difference between those two things, but most likely you're going to want to upgrade your panel if you've got an older panel like this. Sometimes, particularly the fuse box style, might indicate that you've got some wiring that you might want to update as well. Of course, an electrician will be able to tell you that. So these older style ones, I'd say it's very common if you're doing a big electrification project to go ahead and replace the panel, but it doesn't necessarily mean you need a service upgrade. So let's talk about the difference there. So it's important to understand like who owns what in this kind of chain of equipment, from the devices you have in your home that are all connected to your electrical panel, and then back through the electrical meter to the electrical service that comes from utility. So all these things in blue here, so the poles, the transformers, the wires overhead, and in some cases, if you've got underground service, the wires that are trenched underground, all that is owned by the utility, and they provide that to you, mostly free of charge, but we'll talk about what can happen if you need to upgrade those. And then there's all the stuff that you own. There's the red stuff, which is basically this interface between the electrical service and your panel. And then, of course, there's your panel. So let's just say a scenario like that fuse box. You're going to want to upgrade your panel. So you're for sure going to need to do this first part in green, most likely. And typically just replacing the panel is $2,000 to $3,000. It's a relatively modest expense, but and one that's well worth it if you've got an old panel like that. But if you need a service upgrade, which means that you need more amps to the panel, then that starts to trigger other potential things. Like if you've got a 100 amp panel, for example, right now, and you want to go to 200 amps, it's very likely that you don't have enough service to your home to drive 200 amps. So you're going to need new meter enclosure box. You're probably going to need a bigger, fatter wire from the meter to the overhead service lines. And the utility may or may not need to make changes on their end to make sure that you've got 200 amps coming into those wires to your panel. If you looked at that meter like we talked about and it said CL100, well, for sure, you're going to need a new meter. Most likely, you're going to need some upgrading to the overhead wires. And the utilities will do that free of charge up to some certain point. Typically, it varies by jurisdiction, but usually there's some kind of allowance that they have to enable them to make those kinds of upgrades if they're modest. But it's not uncommon to get in a situation where, oh, hey, yeah, we looked into it and we decided that we need to put a new transformer on your neighborhood service in order to give you that upgraded service from 100 amps to 200 amps. And because you're the one who's triggering this, you have to pay that, and it can be thousands of dollars. I mean, it's not uncommon to see these upstream costs, go all the way up to like 20,000. Maybe you need to dig a new trench to locate a larger underground wire. Maybe your meter needs to be relocated because it doesn't meet code. So there's all sorts of things like that that are impossible to predict until you talk to an electrician and in some cases your electrical service. But we definitely hear stories where people said, yeah, I was told if I wanted to upgrade, it was going to cost $25,000. And that's no joke. So, usually it's not that case. Usually it's more in this 3 to 6, under 10, let's say, but it can be more expensive depending on your situation. So what we're going to be talking about today is that there's basically two ways that you could essentially avoid this upgrade. If you've got less than 100 amps, you're probably going to need to upgrade. But if you've got a 100 amp or 150 amp panel, which is not uncommon for older homes like Joe was showing on that chart, you could absolutely electrify your home. We'll show you how to do it. And it's relatively low cost. There's some devices that you might have to add that add some cost potentially, but it's relatively low cost. You're talking about maybe $1,000 or it in that range. The other option is smart panels. These things are really interesting. They're great products. We're a fan, but they're not cheap. You know, we hear that typical installation costs get close to $10,000. There's lots of nice things about these. If you decide you absolutely need to have a service upgrade and you're getting quotes of like 20 grand for the whole thing, suddenly these fan panels or other providers of smart panels start looking pretty attractive, because not only can you do this with less money, but you can save all the time that can be inherent in those larger utility upgrades that can take months to have to get done. We're not going to talk a lot about the smart panel option today. We're going to really be focusing on power efficient design, or you also hear it as panel optimization or the watt diet. But the smart panels are out there as a legitimate way to go. We just are not focusing on them because they tend to be roughly the same cost as a service upgrade. So, you know, they're not attractive in most situations. Okay, so if you're interested in the power efficient design, one of the reasons I love this terminology, power efficient design, because we're talking about efficiency. We're talking about getting more bang out of less power, so to speak. And so it's important to remember that, you know, weatherization and insulation is one of the really important ways to achieve efficiency, particularly if you live in a cold climate, because this can affect the heating solution that you need. That is one of the largest sources of power. So it's always a good idea to do this. I think a lot of times in older homes, again, which are the ones that often need panel upgrades or being told they need panel upgrades, insulation and weatherization is also something you should be looking at. Then the heart of it, though, really is about choosing the right appliances to achieve the things that we want to get done. And every home is going to need heating, and most homes now need cooling. You need hot water. You need to be able to wash and dry your clothes. You need to be able to cook. And more homes also want this ability to charge EVs. These are the 5 largest loads. Everything else, lights, your electronics, even your refrigerator, tiny in comparison to these things here. So when we talk about power efficient design and choosing efficient appliances, we're really focused on these ones that absorb a lot of power. So let's just go through them. A heat pump, for example, you know, if you get a typical 3-ton or so sized heat pump, you can run that on a 30 amp circuit. The ductless ones are super efficient. But if you live in the northern areas and you may be told you need heat strips to come on during the cold snaps in order to make sure your home has enough BTUs of energy to keep you comfortable, that adds a huge load. Now you're talking about up to 60 amps, a whole nother circuit at 60 amps that becomes a huge drain on this budget that we have of 100 amps to start with. So you want to avoid that. And the 2 ways to avoid that are to make sure your home is weatherized and insulated properly, but also get a really efficient heat pump that can basically deliver the heat you need without having to go back to that heat strips for backup heat. That's an important one. When it comes to water heating, we have some really good options now. There's 2 options for 15 amp water heaters. And just as reference, you know, a typical electric water heater is 30 amps, and the hybrid water heaters that are kind of a mix of a heat pump and an electric water heaters are also 30 amps. But you can get 15 amp heat pump water heaters, either 120 or 100 or 240 volt versions. So that's taking a big chunk out of what you need. They're going to deliver all the hot water you need, so you still have that, but you're being miserly, so to speak, on your amperage. And then drying is another place where you can save a lot, because a typical resistance dryer, electric resistance dryer, is going to be 30, in some cases as much as 50 amps required for the circuit. But you can get a heat pump dryer that runs on 15 amps, and these ventless combo machines are fantastic. But now you've got one circuit for both your washing and your drying that's running on 15 amps. So anytime you can combine loads into one circuit, it's another way to save space on your panel and save amps on your panel. So those options are fantastic, and there's more and more products available all the time there. We have some, they're really amazing. Then cooking. Okay, there's not a real fantastic way to say there's some products that are coming online now that might change this equation a little bit, but in general, you're going to need a 40 to 50 amp circuit for a induction range. There's a lot of them that run on 40 amps. Ours is that way, but some of them will require 50. So you want to check that. But the thing that you want to avoid, if you can, is splitting your range, your cooktop and your oven. If you can avoid that, that's another way to save another circuit, because you're going to need a separate 50 amp circuit for the cooktop or 40 amps for the cooktop and another 30 amps for the oven. So now you just added a circuit that you could avoid if you're using a range instead. All right, and then that leads us to EV charging, which we'll go into in more depth on all this stuff later. But this is one where, you can save a lot here depending on what you put in. I think there's this perception that people who are new to EVs that they need a fast charger at home. And so you can look online and you go, wow, I can get an 80 amp charger or 70 amp charger and I can get, lots of miles per hour of charging, and that looks appealing. But if you stop and think for a minute, most people, the average is you're driving less than 35 miles per day. A level 1 charger, most likely, the one that came with the car that plugs right into any available 15 amp circuit, 120 volts, is likely going to give you enough power to charge your car for daily driving. We've lived with 15 amp level 1 chargers in our home for years. We've never upgraded. The next level that you can do, and we have done this before, we've seen people do this, is put a 16 amp level 2 charger. That's the lowest level of level 2 charging you can do. It's the slowest level 2, but it's still amazing. Like overnight, you're going to get 100 miles of charge in a typical EV. So you're with only a 20 amp circuit, this 240 volts. So if you can avoid these larger EV chargers, you're going to save yourself a lot of space on your panel for other things. And so, of course, it's a case of balancing all these things, making a plan so that you can keep within the budget you have, so to speak, of 100 amps. But that's one way to get there, and probably the center of this power efficient design idea. But then there are other things that are available. These really nifty gadgets that are coming along. Circuit splitters are one really cool device where basically, and some of these are just aftermarket things. You literally plug it into your wall. Like you take one of these devices in the center, plug it into your dryer circuit, for example, that's already powering your dryer. And now you can plug your water heater and your dryer into that circuit, or maybe your EV and charger into that circuit as well. And the splitter will only allow one device to pull power at a time, and you prioritize it. So in this case, you'd say, I'll prioritize the dryer. Every time my dryer turns on, it shuts off the power to the water heater. That's not a really big compromise because your water heater is most likely filled with hot water already. So if it just means that you can't heat more hot water while you're drying your clothes. That's a compromise that most people can live with. There's other ones like another good example is splitting a load with a wired circuit, not one of these that you just plug into the wall, but one that's actually wired into your circuits, like this simple switch is an example of that, where you could share the range and the EV charging with one circuit. And so that means you can't charge your EV while you're cooking your turkey. But really, most of the time, you're going to be charging you have plenty of time at night to charge your car when you're not cooking. So these things are one way to save. Another kind of slight variation of that same idea, Simple Switch makes a version of this, for example, it's called a circuit pausing device, which is basically where you get to add another circuit onto your panel without regard to the current load, because this circuit is smart. It's going to turn off whenever it senses that the panel is overloaded. So this circuit pausing device goes between the panel and your EV charger, let's say, and that means that whenever you try to charge your car, it's going to check to make sure that there's available amperage at the panel. And if at that moment you're cooking your turkey and your teenagers are taking long showers and making the hot water heater turn on, and someone's washing and drying their clothes, it will pause and then turn back on when the amperage is available. So again, because at night, which is the time that most people charge their EVs, these other devices are not likely to be used. This is a great solution. There are even EV chargers that are really cool that start to incorporate this feature into them, which is one less thing, which is awesome. Evolution will probably see more of those as time goes on. All right. So I'm not going to go into this a lot, but you can go to Redwood Energy, and our panelists today has done a lot of work with them. But I'm really a fan of Redwood Energy. You can go to redwoodenergy.org, I believe it is, and we'll put the link in the chat. And this watt diet calculator, I've just stolen these images right from that website. But these are two examples of having electrified a 100 amp panel for a 2,000 square foot home and then for a 3,000 square foot home. So it's totally possible to do. Our panelist today is going to talk about examples that he's aware of. He's had a lot of experience in this exact thing, planning for these situations. So this is just just makes it a little bit more real about what it looks like on your panel if you're taking advantage of these strategies. All right, so I want to touch real briefly about tax credits and available incentives. There aren't a lot out there at the moment. For most people, you're going to see this tax credit that's available through the IRA that's about up to $600. It has to be done in conjunction with another efficiency measure, like putting in a heat pump or putting in new windows or something like that on your home. So that's available. It's not, going to put a big dent in the cost, but it's a little bit of a help. And then there is the rebate part of the IRA program that's just starting to roll out. This map here shows that in green, the states that have started to deliver rebates. And it varies by state. This money is all managed through the state programs. Theoretically, there's up to $4,000 available for income qualified applicants to do panel upgrades and electrical wiring upgrades. It's going to vary by state. California, for example, I just was checking, they're only doing these rebates for multifamily properties at the moment. New York State, on the other hand, is starting to roll these out for individual single family homes. So you got to check at the state level. But theoretically, if you meet the income qualifications, there's more money for this kind of work as part of the home electrification and appliance rebate program from the IRA. Okay, so there's lots of benefits. We're going to talk more about this with our panel, but you can avoid, a panel and service upgrade is going to save you money. It's going to push you into these more efficient appliances, which is again going to save you money through operating at cost, and it avoids triggering some upstream grid systems upgrades that we all end up paying for this in the end. And, I talked about that allowance from the utility. Well, where does that allowance come from? It comes from ratepayers. So we'll talk more about that, but there's no free lunch here if you need the electric company to come out and put in bigger wires or a bigger transformer. So there's lots of good reasons to be doing this. And I can't wait to talk about this in more detail with our panelists today. We'll introduce Tom Cabot. He's got 40 years of experience in building science and utility program design, implementation, and resource planning. He's an energy and electrification consultant helping to educate homeowners and contractors and utility operators on the benefits of exactly what we've been talking about as power efficient design practices to avoid these unnecessary upsizing electrical panels and utility infrastructure. Because I can't emphasize enough, the immediate reaction, if you say, I want to electrify and I've got a 100 amp panel, the electrician is going to tell you need to upsize your panel. So this is why this conversation today with Tom is so important to understand how to push back on that, how to think about planning ahead to save yourself money and also avoid these additional costs that really don't benefit we ratepayers. All right, so with that, I'm going to stop sharing and introduce Tom. Thank you for joining us today. It's really great to have you. And yeah, maybe we could start by you just giving us a little bit of I did the introduction there, but why don't you give us a little bit of a overview of your experience in this area and et cetera.
All right. Well, thanks so much, Brian and Joe, for setting all this up. And so my background is I was trained through building science and became kind of a HVAC specialist, got a degree in environmental engineering, but then went to work for a utility, working in their utility programs, eventually became their lead utility resource planner. So I learned a lot about the grid, a lot about buildings. What we're talking about here is that intersection is how do we go about taking advantage of the more power efficient products so that we don't have to upsize as much about the grid? What are the incentives to do that? Who's operating under what types of embedded incentive biases going on for electricians? They may see it as an opportunity just to grow each job size by selling a larger panel, and plus they feel they're doing something prudent for you. But the thing that we're realizing is with these really efficient devices, they give us what we need, because what we need isn't amps or watts. What we need is the cold beer and hot showers and the thermal comfort and the mobility. So we're wanting those things that the energy provides, not the energy. And if you've ever touched a wire that's live, we don't want the energy directly. We just want what it does. So this is all about just doing that design work, selecting from the more power efficient appliances on there and using some controls if you still need controls to close that final gap. So it's really about intentional design instead of passively letting the electrification happen to you and taking everybody's advice for overpowered devices.
Love that. Love that.
Yeah, well, so I mean, how does this approach, why is it important versus just upsizing the panel? And you talked about that a little bit to 200 amps, but if we're able to keep people on their existing 100 or 150 amp panels, why is that important to electrification?
Well, it's really very important for if we're all going to make enough progress to meet the climate goals. If you look at the projections for what it takes to preserve this livable climate under 2 degrees C rise, it takes a lot of transition quickly, and that's a big strain both on workforces at the home level, the electricians, et cetera, who really ought to be busy on the commercial buildings and all that. And because there's tasks we can get done through a better appliance selection, like that combo washer dryer machine that doesn't even need us to install an electric circuit to a overpowered dryer. Just by picking the right machine at the shop and having it delivered and plugged into the washing machine outlet, and it just drains down the washing machine standpipe. But I put dry, dirty clothes in, and I get dry, clean clothes out of it 2 hours later on these heat pump versions. And it's really nice. I never have that mistake of leaving wet clothes in a machine and it getting moldy. So I love these better devices, and just making those selections helps us shrink the size of the projects we're doing at our home. And then that also helps shrink the number of houses the utility has to visit to do their connection work to, or to put into their engineering queues, or to, do that work. And then it lets our transformers out on the poles in our neighborhood last longer and accommodate more neighbors electrifying before those have to be eventually upsized. Maybe we only have to upsize them one time to the next level. But if we all went power hog design, we'd probably go into 2 or 3 waves of upsizing those things. And the cost of all that comes back in electric rates. The utilities spend money on those transformers. They wait in long transformer lines to get those from the supply chain. And so there's lots of things that can slow us down if we're being power intense about it, and lots of ways for us to play limbo under these thresholds and get our needs met if we're going to do the good design.
Yeah, I love that. I love that. I mean, can you speak to a specific example you're aware of where somebody wanted to do this and they were told it was going to cost them 25 grand or something like that? I mean,
yeah, that happens with typically anyone who's got underground service of the wire to their home, and the wires coming up into the meter. Trying to upsize that underground service and digging a new ditch through your yard and re-landscaping, filling that in, getting all that work scheduled and dealing with all that mud. That's just an add-on of typically $20,000. So that's the case where this stuff is just a screaming good deal, but it's also a good deal on the overhead lines where you might be paying, $2,000 to $5,000 for meter for your electrician's work, and then trying to get on the utilities queue. And some of the utilities are backed up many months doing that, which can delay your projects. So, both cases, overhead and underground, they're both worth pursuing. It's worth making the plan to see if you can make it.
I was going to ask Mark is asking in the chat about whether you've seen are electricians and contractors aware of these power efficient designs, or as Brian's saying, is it generally that they're just going to try to upsize that panel?
Yeah, it's pretty new, because the common devices have come down from the power intense side. even the heat pump water heaters, the common hybrid heat pump water heater that's most often sold is the 30 amp direct replacement going onto the same breaker as the resistance water heater used to be. It was also 30 amps. Those two machines are electrically very similar because the heat pump version, the hybrid version, only has this energy saving heat pump on it. It still has the same power intensity in its backup. But these, more power efficient versions like the 240 volt 15 amp one, it's a special order, but it's the same price. If you order it, say through Home Depot, it's the same price as the 30 amp one. It just takes another week to get it. So you may want to pre-order it. And just picking that one saves the 15 amps off that calculation, although the amperage in those calculations is multiplied by coincidence factors. The code calls them demand factors, but they really have to do with the assumption about how coincident is that device's peak load with your whole building's peak load. Almost every device you have is only about 40% coincident among these 5 things we're looking at adding, except for the heat pump. The space heat pump is assumed to be 100% coincident with the building load. So we'll count all the amps on that nameplate that it has. And so in this design method, we're looking at the nameplates of the appliances. You're picking those 5 things: the heat pump water heater, the drying system, the cooking, and then the flow setting on the EV charger. And for the EV charger, we take that flow setting, and because it's a long duration load, lasts more than 3 hours typically, the code has us multiply that by 1.25, which takes into account that over a long time, this wire embedded in a wall might build up heat and temperature. And the code is trying to keep that wire safe. So what they say is count it at 125% of the flow through it. And that way you'll be picking a wire size that won't overheat, even embedded in a lot of thermal insulation. So we take that 125 number, and it also gets multiplied then by that 40% coincident, because even though it's long duration, the whole building's load is not a long duration. So they allow that coincidence matching, and then we're able to get through those calculations. And these are the part of the code which they call 220.83b, and that's a building the bottom up type of load calculation for a single family dwelling, or there's other similar for multifamily dwelling. And then I saw someone in the chat was also mentioning, when you go project by project, it's kind of nice to use another part of the code, 220.87, which lets you take a look at your actual peak usage for the highest hour of the past year or highest 15 minutes. It'll take either number. They're pretty close to the same. And you say, okay, that's how much of my panel's already occupied by everything I'm doing. And then there's this much space up to the rating of the panel, and a 100 amp panel times 240 volts is 24 kilowatts of capacity. Most homes are peaking only at 8 kilowatts in their highest hour of the whole year.
Wow.
There's another 16 kilowatts of space. And so you can slip in another couple of nameplates above there, and then your building load digests them because they aren't all really super coincident with the other 8 kilowatts. And then next year, when you take a look at it, your peak might only be 12 kilowatts, and you still have 12 more above that.
Yeah.
To get to 20.
I want to come back to that. I want to just put a little exclamation on your example of the 15 amp heat pump water heater versus the 30 amp ones. And Joe and I both had this experience, and a lot of people that I know do, that you buy the 30 amp one and you put it on heat pump only mode. You're never using anywhere near 30 amps. You're using a tiny amount of that. That 30 amps was in case the electric resistance elements get triggered. So my point is that choosing this 15 amp version of it there's no downside really from a usability standpoint, because if you're using it on heat pump only mode, which is what you're going to want to do because that's the way you're going to save the most money. And if you've got a properly sized unit, you're going to have tons of hot water. So that's not an issue. So there's really not a big disadvantage by going to this more like, power friendly version. And I think that's true in a lot of the cases, with what we're talking about. That's sort of what we were talking about with EV charging as well. There's really no penalty to go to a smaller size charger, unless you're driving a lot of miles.
Right. So there are two unintuitive things that people probably need to try to learn about. One is on the water heater, there's no penalty for getting a bigger tank. And the bigger tank's what's going to deliver more rush hour hot water for you and keep more guests happy. So go as big as you can fit in your space and your wallet for the tank size. And then the other trick is to set it up and use a thermostatic mixing valve. Some of them have them built in. Some of them you can add them on the side, or you can always retrofit these things in, but they let you overheat the water heater, say to 135 or 140, and then it mixes cold water in to give you a safe 120-degree delivery temperature.
Yeah.
And so then by having this overcharged water heater, you've got even more energy stored. So you're now using it like a thermal battery. So doing that. The other unintuitive thing for people is our EV batteries, in cars, they've gotten longer range and bigger batteries. And you're thinking, bigger battery, I need a bigger charger. And no, bigger battery means I can slop energy from day to day to day. And I can build up that range over a few days and go on those big trips and drive 2.5 times as far as my charging range is in 8 hours.
Yeah.
Because I've built up the charge. So we need to kind of learn what is happening in product design that's helping us get this done easier. And it's getting easier as we learn it. But a lot of the trades, they're not taking that into account yet. And so that's why we're still getting the oversized advice from the trades while we're getting more solutions available.
And I mean, my experience is a lot of the electricians aren't even aware of these things like the Neo splitters and the circuit sharing devices. Those are relatively new things, and so, in some cases, the consumers might be ahead of the trades on some of these things, which is why it's important for all of us to get educated on this, so we can, find the right contractors and then know how to work with them.
And I guess on that note, Tom, you were talking about some of the calculations that you want to do. Brian mentioned that Redwood Energy has that. Is that the resource you would point people to start to calculate what loads they have? What's a good resource?
Right. Yeah, that's a good one, that watt diet calculator. There's also one that's come through the Cal Next program in California that has more guidance built into it about trying to tell us what choices to make. I've been kind of redrawing some cities' online electric load calculators because they'll publish a spreadsheet online. One of the problems is it only gives like one common default value for the wattage of each device. And it's like with water heaters, well, no, now we have 4 different wattage levels for these devices. And so you could be picking the new 120 volt plug-in heat pump water heaters that are only using either 400 or 900 watts. And so they're really a tiny load on the calculation. You don't need to just use their 4,500 watt default number.
Mm-hmm. Right.
Yeah.
Right. So let's talk a little bit about this. I know you've had a lot of experience with actually helping people to make plans, because I think that's one of the things that I really kind of feel like I've taken away from like trying to dive into this is that, it's hard to do this like one-off, one appliance at a time. You really need to, if you want to stick within this budget you've got of 100 amps, let's say, or 100, even 150, you need to be thinking about, okay, what are all the things you want to do, and how do I do those in a way that's going to stay under this budget? So can you talk a little bit about this planning process, or how you think about it, and what tools you use?
Right. So it can be done with that the watt diet calculator from the Redwood Energy site that can be used, or this CalNext site. There's also firms offering to make these plans for you. So you can use one of those consulting firms who will make a plan, like Quit Carbon's one of them, and they operate for free, and they're compensated by contractors who participate and get the jobs installed. But anyway, so there's different ways to get a plan together. The 5 end uses, we've kind of talked about them, that thermal comfort one. And a lot of times for folks who already have air conditioning, the heat pump load is roughly the same, but you can get a heat loss calculation done to help you really zone in on right sizing that. And if you use ductless heat pumps, you can actually cut about 20% off the sizing of the heat pump, because at the peak conditions, the peak coldness or peak heat, if you've got ducts in the attic, you're losing 20% of the capacity into the attic through leakage and conduction of ducts. So going to ductless can save you 1/5 the heat pump size. And then carefully selecting your equipment. We've got on the market now 3-ton heat pumps that only draw 17 amps, and they can go on a 20 amp circuit. And that 17 amps goes out to the outdoor machine, and then it has an umbilical cord along the refrigerant line set going to the indoor air handler on the
Right. So
where
you're
the
using
furnace
one
head.
circuit for both. Yeah.
Right. So
Yeah.
you've got a 2-pole 20 amp circuit powering the whole
That's
shebang.
amazing. Yeah.
And
Like
so
in my
you don't
home,
need
in my home,
separate.
we've got an older style one. I think we have 3 circuits. We have one for the outdoor unit, one for the air handler, and one for the heat strips. So, we are absolutely not power efficient design.
Right. That's five
Yeah.
poles
Yeah.
being used. Probably, one, the reason it's 2 poles outdoors, 2 poles resistors, and 1 pole running the 120-volt blower.
Yeah.
But yeah, it's nice to get, to start learning about these other mini split versions that can get you down to 2 poles used. That's the other thing. We've been talking about amps, but we also want to be looking at how do we shoehorn this in all the new end uses we want on the existing poles we have, or do we have to build a little sub panel or set a sub panel there to get a lot more spaces?
Right.
But now that we've got so much LED lighting that's
Yeah.
using 1/8 as much power as our old lighting, it's possible to combine several of our existing lighting circuits in a junction box or a pigtail, even the panel, and then connect the several of them to the right size breaker that protects all their wires. If they all were 15 amp wires, you join them together, you connect them to a 15 amp breaker.
Wow, that's a good hack there, Tom. We're getting a lot of questions on circuit splitters, so I've been trying to I pulled a couple together. So let me ask 3 of them real quick, and I'll remind you if you care. Are circuit splitters code compliant? You need an electrician to install them, and when you pause a branch circuit, will some appliances have a hard time restarting?
All right. So yes, they're code compliant. And what the code is saying about them is that you need to be taking the larger of the 2 loads on a circuit splitter. So let's say you've got a 30 amp dryer and you've got a 20 amp car charger set up on it. You would be taking the 30 amp dryer and sizing that, or sizing the breaker for that. So 30 amp breaker, and then you'd be counting that dryer in the load calculation, not counting the smaller of the 2 loads connected to the splitter. So they're code.
Tom, sorry, just on that. I mean, I think it's true also, isn't it, that like in case of Neocharge, for example, so if you're using the larger one, I think the actual Neocharge unit you buy is also sized, isn't it?
Right.
According to the amount of amps that's running through it. So you need to make it right. You need to choose the right one, I guess is what you're saying.
Right. And then also on those plug-in versions, you need to choose the right plug face type. Some are 3-prong, some are 4-prong. So anyway, do look at your dryer outlet if you're going to be plugging something in there.
I know the Neocharge on their website, I think they have a pretty good kind of like question and answer thing you go to. It asks you what you're planning to connect, blah, blah, blah. And so to make sure you get the right product from them, but that's important.
And then the way theirs, and I forget who else is doing it, but they still will supply, say, 250 amps, watts, 200 or 300 watts to the primary device, even if it gets turned down. So let's say you're drying your clothes and it reaches the end of the cycle and it drops down to 10 watts. Well, then that, since it dropped under 300 watts, it lets the car charger start up, and the car charger can be taking its full, 8,000, well, no, it'd be more like 4,000 watts that it wants and be doing a 4 kilowatt charging for you.
Yeah, that's great.
Did we get the other two?
Let's see, there was one I was
You need an
wanting to
electrician
mention.
for
There's
circuit
plug-in
splitter?
devices like Neocharge is a plug-in, and then there's also a hardwired version that would involve someone with electrical skills installing it. And so if in your family that's an electrician, then you would hire an electrician.
Great. And
But
the
it
last
is,
one was, if you pause a branch circuit, do some appliances have trouble restarting?
yeah, let's see. What do I know? I think like a heat pump water heater, if you cut the power all the way to it, it may want to restart as a new install. And so it may want to run through its startup routine of testing its resistors and things like that. But usually the thing that the thing that we're cutting all the way off is like the car charger, which is fine. They're used to being unplugged and plugged in at a new location.
Yeah. I mean, I think that's one thing on these circuit splitter too. We were talking about it before we started the show today, that these plug-in ones, like the ones that we should, like the Neocharge, for example, those were great if you've got two things that are nearby each other. Like for instance, like a common application is a dryer that's in a garage, and you want to use that same 240 volt circuit to power your EV charger. So you plug this thing into the existing dryer circuit, plug your dryer into the box, and plug your EV charger into the box. If you've chosen the right size thing, that's a pretty easy setup to do because these devices are right next to each other. Then there's another situation where maybe you want to share, like the one that we used in the presentation was an electric range and an EV charger. Those things are not next to each other most likely. So this is where the wired in versions come in really handy, because you get an electrician to put that in the right place in the electrical chain, so that both devices are getting the power they need. That's going to take an electrician to do that. So it's good to be aware of both these options, depending on your situation.
Yep.
Tom, are there any like stories you want to share from folks who've done this work?
Yeah. So we've been helping people by making these plans, and what we see is that it's really useful for them in guiding each of the trades they're going to deal with separately, and guiding them towards the power efficient device, and showing them how much power budget they have, how many amps they have in the panel available to the choice they make, and how many pole spaces they have in the panel. And so we're helping people get these full electrifications done on their 100 amp panels in California, in the Bay Area. It's pretty easy, and that's where we've been doing most of our work.
There's a good question here about subpanels, and you touched on it, Tom, but the question is, is adding subpanels okay? And, let's just talk about subpanels for a minute. And just to clarify what a subpanel actually is, it's really just giving you more breaker space. Isn't that the way to think of it?
Yep, that's the way to think of it. It doesn't give you more amp capability on the service line or the main panel, but it does give you more breaker spaces to connect to. So it's like a power strip, but it's a permanent version of a power strip with protection on each branch circuit. Branch circuit is the name for a circuit going out into your house, say either to a single device or to a string of outlets. And so that's one of the 11 ways to get our needs met within the existing breaker spaces we have, is to take two poles and use them for a sub panel that then can provide, say, another 10 poles or 15. So it can do
I think that's a good point, because it's one of the realities of these smaller panels, like 100 amp panels. We've talked about there's two factors: how much amperage is coming into it that enables you to power all your devices, and the second is how physically big it is to allow you to have enough breakers for all these devices. And so subpanels solve the problem for the second situation, where you just need bigger space, and they're relatively low cost to put in. I mean, in the big picture, it might cost you a couple $1,000s to put in a sub panel, or I don't know, maybe not even that. But compared to a whole service upgrade or a new panel, it can still be lower cost. So it's a nice tool to have in the toolbox.
Yeah, I'll just mention a couple of the other ways we can get twofers out of the choices we're making. One is the 120 volt heat pump water heater, big tank and all that, but it's only using one pole. Some of them, so it's only a 120-volt device. Even if you were to run a dedicated circuit to it, it would only take one pole to do that. But most of the models that have come out are shared circuit models.
Shared
They
circuit.
can go on a circuit that's got several outlets in it because they're using 900 watts or less. So
As long as there aren't big other draws on that circuit.
Yeah.
Yeah, another is each of those splitters we've been talking about is a way to get two things done on the same pair of poles. So that saves two poles for each time you use it. And then the other one is, the combo washer dryer thing. So getting two functions, and that saves the two poles that would have gone to a dryer. And then using a range instead of having a separate wall oven saves the two poles that would have gone to a wall oven.
Right. Yeah, lots of creative ways to really make space in your panel.
Yeah, and
Yeah,
then I mentioned that one
um,
about combining some of our now underloaded lighting circuits through a little junction box or pigtail to free up their poles. And
I see that Helen's made a comment here in the chat that she used the simple switch. That was one of the ones that we showed in the presentation between our induction range and EV charger. So, I think it's important sometimes to know that this stuff we're talking about isn't just theoretical. People are actually doing this, but it's a little bit on the front edge of this because it's becoming more of a question. And so I think it's important that we all educate ourselves on this, but it is being done. Joe, do you have any other questions you think we should?
I think we're good. This has been fantastic. I think we covered our main points, got to a lot of the audience questions. Tom, anything you would like to leave us with?
well, I just want people to know it's doable. It's getting easier. And now we've given you some hints about where to find the resources and how to kind of stand your ground and get your electrification done on your existing panel and do as much as you can yourself through your own planning and your own device selection. And you can make this a lot easier process for everyone.
I think that's great. That's great. Thanks, Tom. And I think one thing I would add to that is that what I'm seeing is that the HVAC contractors that are on the front edge of electrification, the ones that talk about electrification on their websites, not just the devices, but they put it in context to electrification. A lot of those players are getting more familiar with this concept of the watt diet, et cetera. So if you're getting advice from either your HVAC contractor or your electrician to upsize your panel, and based on this conversation, you think there might be a way around it, get some other advice. I mean, I think that's the best thing to do. Look for HVAC people that are familiar with doing this and have done it themselves. Look for electricians that know how to do this. And again, we'll try to help you with resources. I wish there was one place I could send everyone to find those resources. It's not quite that simple, but there are good resources for this at the state level. And feel free to reach out to us if you have questions about this. We'll try to point you in the right direction.
All right. Well, with that, we'll say thanks again to Tom. Thanks y'all for joining us. Let us know if you have any questions. And as we say every webinar, good luck on all your electrification projects.
Thank you. Thanks, Tom.
Thanks, everyone.